Using fread and fwrite, we have learned how to read and write binary data to files. In particular, we've learned how to write individual values and arrays of values. There's one more popular use of fread and fwrite, which is to read and write structs. There's no new syntax here and no new concept really. Think of it as an important application of something that you already know. If we had a struct student and we wanted to write such a structure to a file, we could separately write the first name, write the last name, write the year, and then the GPA. But this is tedious, especially with a large number of structure members. Reading or writing entire structures at once greatly simplifies our code. Let's work through an example of writing structs to a file. We are going to write some student structs to a file. So we declare a file pointer and then open a binary file for writing. The file is called student data. These 4 lines populate the 4 members of a struct student variable s. And then we write the struct s to the open file using fwrite. Most of the parameters are the same as when we were writing individual values. The interesting parameter is the second one, where we use size of to determine the size of the struct that we are writing. It's very important we use size of instead of manually computing the values of the struct. It seems possible for us to compute the struct size. We know that the first name is allocated 14 bytes and the last name is allocated 20 bytes. Most likely, the year will be 4 bytes and the GPA will be 4 bytes. So perhaps the entire struct is 14 plus 20 plus 4 plus 4, that's 42 bytes. However, we are guessing at the size of an integer and float. And even if we knew those sizes for certain, we still wouldn't know the size of the struct. This is because C is allowed to insert space between members of a struct. Moving the members a little in memory can speed up memory accesses, and it may even be required by the computer running the code. For example, most machines require that integers start on an address that is a multiple of 4. So the compiler will add 2 bytes of padding after the characters to make this happen. Fortunately, we don't need to guess what the compiler has to do. We can ignore it as long as we use size of. Let's go ahead and write a second struct to the file too. Here we change some of the struct's members and then write the struct to the file again. Now the file has 2 structs in it. Notice that our first name is allowed to be 13 characters, plus a null terminator. But the name doesn't always take up the full space. For example, Betty is only 5 characters, plus a null terminator. What happens when we write the entire struct to a file? Let's find out. Let's compile and run the program. Running the program creates a file called student data that contains the 2 structs that we wrote to the file. Let's use OD to see how the name Betty is being written. We know that characters are 1 byte, so we have OD present the data as 1 byte unsigned decimal values. We also know that the characters should be encoded as ASCII. Looking at the first 7 characters, we see B, E, T, T, Y. The 6th character is a 0, our null terminator. Now we need to find the start of Holberton. The value for H is 72, and we see it at position 15. fwrite places all 14 bytes of the first name field into the file, even though we only use the first 6. In this video, we used fwrite to place structs into a file. We can now use fread to read the structs into a program to extract and use their values. We encourage you to try that before continuing to the next video.